All right, so in this video, we're going to be continuing on trends in the periodic table, and we're going to be talking about chemical families. And chemical families are something we've already seen before. They're the groups in the periodic table or the columns in the periodic table. And we'll see why they're arranged the way they are, but elements in the same group have similar properties. For example, the alkali metals like lithium, sodium, potassium, all have similar reactions with water. And they're actually quite violent reactions. There's some YouTube videos you could probably find of people throwing hunks of potassium in a lake or a bathtub, and I'll let you see what happens with that. Likewise, elements in group 7A, the halogens, which we'll talk about in a second, all undergo similar reactions with metals or other nonmetals, and some of those are shown here. Okay, so families occur because the atoms of the elements in the groups have similar valence electron configurations. And these valence electrons are the electrons that are involved in bonding and reactions. So because the elements have similar valence electrons, their properties are also similar, okay? And this is just some pictures showing that the way they look, different things like that is similar for all the elements in a chemical family. And again, that has to do with the number of valence electrons. So here's some chemical families to know, kind of on the left here. You have the alkali metals, group 1A. So this is 1A right here. These have one valence electron. They have the NS2, or excuse me, I take that back. NS1 electron configuration. All right, so one valence electron, NS1. And the representative reaction in this case is a sodium atom losing an electron. Okay, and so they have all similar properties. Again, the next one in group 2A, shown here, these are alkaline earth metals, okay? They have two valence electrons. They have an NS2 configuration, and the representative reaction here is a magnesium atom losing two electrons. The halogens are all the way over here, okay? Let me just move my screen a little bit. So halogens are over there in group 7A, and they have 7 valence electrons. They have this NS2 and P5 electron configuration. And if you're unsure about that, you can go back to videos when we were talking about valence electrons, and that'll give you more of an idea of what I'm talking about if maybe you missed that video. And the representative reaction here is chlorine gaining an electron and becoming a chloride ion, which is something we're going to talk about a little bit more in chapter 6. The noble gases are over here. These guys have NS2 NP6 configurations. They have the full 8 electrons there. And so they don't have any representative reactions. They're happy just the way they are. They're non-reactive. So they're noble. They don't like to change or to react or anything like that, okay? They don't like to mix with the other elements, I suppose, for better or for worse, but they're the noble gases, okay? So they have no representative reactions. And then finally, I just want to mention hydrogen. He's here, okay? And hydrogen doesn't fit into any chemical family. So even though it has an NS1 configuration, hydrogen is special. It's not really an alkali metal, even though it's found in the same column here. So just keep that in mind, that hydrogen here is special. You can also see here the transition metals. They're kind of in the D block of the periodic table. We're going to be talking more about them as the semester goes on. And then there's the lanthanide series and the actinide series. We're not really going to be talking about that very much in this course at all, but just know that they're there if you go on to maybe general chemistry or another chemistry class. Okay, so moving on then, we're going to talk about this trend called metallic character. So metallic character is, well, exhibited in metals. It's physical and chemical properties of metals. So for example, here's a table showing many of those properties compared to nonmetals. And so metals, for example, can lose electrons easily to form cations. They have low ionization energies. high electrical conductivities, just naming a few of these. They're malleable. You can make them into sheets, hammer them, form them into things. Whereas nonmetals are pretty much the opposite. They tend to gain electrons, not lose. They have high ionization energies. They're poor electrical conductors, and they're brittle usually. Okay, so for metals then, the ability for it to lose electrons, okay, to lose its valence electrons in a chemical reaction, the greater that ability, the greater its metallic character. All right. So, well, whoops. Okay, so something's going to go there, I guess. So, metalloid or semi-metal elements that have some properties of both metals and nonmetals, and they're found here. So, I guess I was writing on this beforehand. So, if you look at your periodic table, there's kind of a staircase there, probably in red on your periodic table. It's black here. And these elements, so this is in red on my periodic table. These elements here are the metalloids or the semi-metals. So things like boron, silicon, germanium, arsenic, antimony, tellurium, and an element at the bottom whose name I do not know. Okay, so these are the metalloids, and their properties kind of border between being like a metal and being like a non-metal. They're kind of in that transition region. Okay. So they're the metalloids. Okay. So then the trend for metallic character, how do we kind of think about that? Is metallic character generally increases from right to left across any row of the periodic table. And so for electrons whose valence electrons have the same principal energy level, as the nuclear charge decreases from right to left, the electrons are held less tightly. And remember, in order for something, when something has a, when it's easy for something to lose an electron, that's what I meant to say, it has a higher metallic character. Okay. So that's why it increases going from right to left on the periodic table. Okay. And metallic character generally increases from top to bottom in any column of the periodic table because valence electrons are in increasingly larger orbitals and are more distant from the nucleus. So the electrons are held less tightly. And again, if something can easily give up an electron, it has higher metallic character. Okay, so here's a summary right there, and you can use that similar to how we talked about ionization energy, atomic size, to rank things in order of increasing metallic character. All right, so that ends this chapter, and in the next chapter, chapter 12, we're going to be talking about chemical bonding. So I'll see you there.